Continuation of data analysis using R Studio. I am so excited to give you this lesson because in this lesson you are going to learn how to do all the analysis you need, the basic analysis that you need for most researchers, be undergraduate or postgraduate. So what I mean by that is we are going to look at, we'll begin from generating an EDA report, which is exploratory data analysis report, and then we'll look at generation of the descriptive statistics table. We'll look at generating the table of inferentials, okay, the table of association, and then we'll look at how to generate the univariate logistic regression analysis and the multivariate logistic regression analysis, and how to merge those tables for good presentation of your results. So this is actually the only data analysis course you need, because you're going to learn how to do all these in 15 minutes. So without wasting much of your time, let's get started. So we are going to begin with this research that is here. We have the research topic. So the research topic says analysis of survival outcomes and associated factors among ICU patients. So assume this is your research topic that you have, okay? This is just a hypothetical analysis research question, and this is the general objective. So you want to evaluate survival outcomes and identify the factors influencing survival among ICU patients. Now, I have to give a disclaimer here. This topic requires us to do survival analysis, but I'm not going to do survival analysis. I'm just going to do the basic logistic regression analysis, but the main idea here is that you should grasp the concept behind data analysis and how to do it so easily. So let's look at the first objective. The first objectives ask us to assess the proportion of ICU patients who survive, let's say those who do not. So when you look at this research objective, you have to think what statistical test am I going to use? So this is basically proportions, okay? We're just going to look at how many patients were alive and how many patients were not alive, died, okay? And then the other one looks at it to examine the relationship between demographic factors and survival outcomes among ICU patients. Okay, perfect. We'll look at that. And then, so meaning that here we are required to do some relationships between age group, sex, as well as whether the patient survived or not. So at this point, you have to determine, okay, you have to look at which one is your dependent variable and which one are your independent variables. I will explain what that means in a minute. And then the last objective is to analyze the association of clinical and emergency factors. So these are the factors listed there with survival outcomes. So we have looked at this, okay? You have to make sure you understand these objectives, okay? And then you have to look at your data set. So let's look at the data set. So I got this data set online from some website. It's commonly used for practice of machine learning and data analysis. So we have these research variables here. Okay, these are variables. So this variable survive, age group, sex, infection, systolic blood pressure, pulse, and emergence, whether the case was an emergency or not. Now, so this is the one that tells us whether the patient lived or did not live at that time, you know. So, and then you look at the main objective says to evaluate survival outcomes and identify the factors. So meaning survival outcome becomes a dependent variable, okay? This is a target variable. And then the remaining variables become what we call either predictor variable or independent variable, meaning that they are the ones which are determining whether the patient is going to survive or not. But we have to determine exactly through statistical tests which ones of these are responsible. So let's open RStudio. So I'm using the online version. So the next thing that the first thing that I have to do is upload the data set. Okay, so I'm going to upload the data set. So the data set is titled ICU. Okay, there we are. Okay, so the data set is there, and then now I have uploaded. Now I have to import it here. because I'm using the online version, so the process are a little bit different. So I just have to do this and then Excel. Now, what I was doing is I was just putting that data set in a folder. So now I'll go to that folder, okay? Okay, here it is. So I'll select that and import. And okay. So that is the data set and just import. Okay, there we are. I have imported, okay, so and this is the code that has been executed, okay? This is the code that has been executed, and to view the data set, this is the code that has been executed, view, open bracket, ICU. So this is the name of the data set. So we are able to see the data that we saw from the Microsoft Excel here, all right? And then when I look at this side, I'm able to see that in my environment, the data set is there, okay, which is very good, all right? So I'm going to just close this. And then I already wrote a code so that, you know, the process is, we don't take much time. So let me just expand. I already wrote this code, okay? So we are going to follow this code. You can pause, okay? You can pause and copy the code. So the first thing that you want to ensure is that you are working in the directory of the folder, okay? You have set the RStudio working directory into the folder so that the files that you are saving will be saved in one folder. So to do that, you are going to click on session and then set working directory and then choose directory. So I'm going to select this same class, okay? The folder named the class, all right? All right, that is done. That's the first thing. And then second thing, you want to install the necessary packages. So this code is going to install the packages, and these are the packages that you are going to need for the sake of this analysis, okay? But I've already installed the packages. Hopefully they are already installed. And then the next step is to ensure that you load the necessary packages. So as you can see, I have, you know, I have made sure that I have labeled the code, these codes nicely, okay? So I'm just going to copy this everything, then Control Enter on my Windows to ensure that my packages can load. Okay, so let's see what happens. Okay, all right. So I have attached the packages. Okay, this is good. All right, yeah, that is good. And then the next step that we are going to do is we've already set the working directory and we've already loaded the data set, okay? Now the next thing is to attach the data set by running the command attach, okay? Let me just zoom in a bit. By running the command attach, open bracket ICU. So you are attaching the data set, okay? That is done. All right, once that is done, and the next thing that you have to do is exploratory data analysis, okay? Exploratory data analysis. So the package you are using here to do the exploratory data analysis, so the exploratory data analysis just gives you, you want to understand the distribution of data, you want to know the normality of your data, whether your data is normally distributed or not. So the code that you are going to use is this one here, okay? ICU, the name of the data set, and then you are going to use this code, so there's percent greater than percent. So this is an argument used from the package Tidyverse, okay? And then EDA report is the command, okay? EDA report, and then you open bracket target survive. So I'm saying that this survive is my target variable. Remember, you are supposed to know your target variable. So when you control enter here, or alternatively, you can just click on run, and then it's going to give us the EDA report, okay? The package that is used here is DLooker. So we have this exploratory data analysis report, which is in detail. Most of you who have been analyzing data, you know that to do exploratory data analysis, there are a lot of things that are required. You have to go step by step, but DLooker package in RStudio simplifies this process for you. That everything is already done, so meaning I don't have to do that. I just have to look at this, okay? So you can see there's even a table of contents, which is quite amazing. The first thing that you are going to see here is just the information of the data set. You can just read through there, okay? about EDA report and everything. So let's just scroll. So these are univariate analysis. As you can see, survive. How many survived? No, 40. Yes, 160. Okay, so those are the univariate analysis. But that's not really my main interest. My main interest is here. I want to understand the normality of my continuous variables. So to do some normality tests to understand whether your data is normally distributed or not, there's the test that we use. One of the tests is called Shapiro-Wilk normality test. There's also Kolmogorov, okay, but for the sake of this, they have used Shapiro-Wilk normality test, which is also okay. And we are looking at age, okay? So Shapiro-Wilk normality test assumes that your data is normally distributed. That's the now assumption. Your data, that's your now hypothesis. Your data is normally distributed. Then you are going to look at the p-value. As you can see, this p-value, okay, it's exponential negative 0.8. So which means that this is way below 0.05. The p-value is less than 0.05. So in that case, we are going to reject the null hypothesis that age is normally distributed and adopt the alternative hypothesis, that is to say our data is not normally distributed. So as you can see, there's skewness here and kurtosis. In some later lectures, I'll explain to you what skewness and kurtosis is, okay? But basically, skewness just measures the symmetry of your data, okay? So if your data is the skewness should be 0, okay? The skewness should be 0. It means your data is normally distributed. But if the skewness leads towards the negative, meaning it's negatively skewed, or if it leads towards the positive side, meaning it's positively skewed, okay? Yeah, so as you can see, even kurtosis there, which tells us the tailoredness of the distribution. But the good part that this thing does, okay, the good part is that it also does some transformation of your data. Remember, if it's not, your data is not normally distributed, you can transform it. So the basic transformations that we usually do is either log transformation or square root transformation. Now, for visual aspect, okay, for visual aspect, look what it does. So original, this is the normal, okay? So as you can see, this data, to me, looks negatively skewed. We can see the tail is longer on the left. It looks negatively skewed, okay? So this is not a normal distribution. So, but when you do log transformation, you can see that the skewness has somewhat been reduced, okay? So you can see, and then the square root transformation, so it does the log transformation and square root transformation so that you can choose which one is going to be better for you. And the same has been done for the other numeric variables as well, okay? So I mean, we are not here to discuss much into details of the interpretation of this. I just want to show you how everything is done. So now that we've done that, now I have to tell you to say the next step that we are going to do, you don't need really to know the exploratory data analysis because the code that we are going to use already does that for us. Can you imagine? It chooses which statistical test is appropriate. So the next thing that we are going to do is generate table 1. Okay, generate table 1. So how do we generate table 1? So we are just going to say, okay, descriptive statistics. Okay, so this is the table of descriptive statistics. Okay, so let's look at T1. Okay, so T1, I'm naming the name of the table. It's going to be called table 1, and then the command is tbl underscore summary ICU. So let me just do that. Control enter, and then you are going to see magic. Okay, you are going to see magic. Now let me view the table. So I will just press control enter. Okay, so and then we'll be able to see the analysis has been done. So let me just zoom this, and you're able to see some amazing things. So you can see this table, it looks very beautiful. It has already been done for us. There's nothing much to do for it. You just have to copy it and paste it in your document. But for the sake of this, I'm going to show you the simpler way of doing this, and you are going to see it. Don't worry. Okay, so the next thing that we are going to do is we have to ensure that our dependent variable is binary. Okay, we have to ensure that it is binary. That is 0 representing absence of the outcome and 1 representing presence of the outcome. And this is the code that we are going to use. Okay, This is the code. So I'll just have to run that. Okay, perfect. And we can see the name has changed now to survival outcome. This is the new name that I've given it. Okay, and then you can do this to just confirm, and you can see, all right, perfect, that is done. All right, great. Now, here you can now select, you can organize your data, okay, into groups. So for example, I'm going to put demographics, okay, demographics. So I'll say ICU, so pipe select. So I'll select the variables that I want in the demographics. So I'm just organizing my data here. So there's nothing strange. So control enter, I've done that. And then also clinical variables, okay. Control enter, I've done that. All right, perfect. Now I'm going to generate a table summary. Remember the objectives, okay? The objectives. So to examine the relationship between demographic factors and survival outcomes. So this, what I'm going to do is going to answer this objective, all right? It's going to answer that objective. So let me do that. Demo summary. So this is GT summary package, and you are just going to run this code, which tells us, let's say we are going to look at demo. We are going to summarize demographic variables by survival outcomes, and we need to add the p-values, okay? So let me just control enter, and that has been done already. And to view that, we can see this demo summary. So I'll just say, okay, on demo summary, this is the code, just enter, and then boom, we have it. So let me just zoom this, and you see that the table of association has been generated for us. Like I said, you don't basically have to know which statistical test you're going to use based on the exploratory data analysis report. You see, it has already told us here, it has used Wilcox on rank sum test, okay? It has used median because it noticed that the age was not normally distributed, okay? And you can see this is a perfect table with p-values already in it. Perfect analysis, okay? Now, let's look at, let's do another one also for clinical summary, okay? So I'll do this. So this is the same, but we're doing it for clinical. Remember, we have both demographic and the clinical variables. So I'll do this, control enter, okay? I can also view this, okay? So you can see this has been done there, all right? Let me just zoom this to ensure you people are able to see. Why am I coming this side, okay? To make sure that you people are able to see, all right? Now, this is where the cool thing comes, okay? This is where the cool thing comes. I'm going to save these tables in a Word document. So I am going to first convert them. So we have the demo table, okay, the demo summary and the clinical summary. So I'm going to convert them into a flex table. So flex table is a package that is used to present tables in the standard reporting format, which is called the APA, American Psychology Association. So to do that, I'm just going to run these simple codes that you can just copy and run them on your RStudio as well. Control enter, all right? And then we create a new Word document by running that code, okay? And then after creating the new Word document, we are now adding the titles and summary tables to the document that we have created by simply running this code. So control enter, all right, perfect. Now, after doing this, I'll come just to files, okay? And then I'll find this summary document. As you can see, I named it a summary document. So if I open this document, you are going to see something very cool. So let's open this, we see. Let's open this, okay? I've downloaded it, so file show. Let me just open this document, and you are going to see that RStudio makes everything absolutely easy for us to deal with. And you can see how cool is this. Oh my God, you can see the table 1 has been generated nice for demographic summary. I mean for demographic values that are factors that are associated with the survival outcome, okay? And the clinical summary as well, okay? So now here where there's 0, I can just say, okay, survived, and then where there's 1, died, okay? And you can see these tables are beautifully presented here, all right? So now we have done that. Now let's look at, let's go further into doing now what is called logistic regression. Now, why are we doing logistic regression? Here, I'm not interpreting. I'll record a separate session to interpret these results, So for now, I just want to show you the practical data analysis, okay? So we have done the tables of association or statistics of association, but these, they just tell us association. So for us to present our results in publication ready, okay, report, we have to ensure that we do logistic regression. So logistic regression tells us the effect size, okay, the effect size of the association, how much association, how much is the systolic blood pressure explaining how the survival outcome of the patient, how much is the infectious status, whether the patient had an infection or not, is explaining the outcome of the survival of the patient, okay? The tables of association will just tell us whether there is an association. Remember, association is not equal to causation. So we have to estimate, we have to do some regression analysis. So remember, in regression analysis, there are two tables you are going to do. There's univariate regression analysis and multivariate. Univariate just means you are not accounting for confounding variables. You are just looking at what's the relationship between age and survival outcome, but you're not looking at whether sex affects the survival outcome. You're not looking at the others. So that's the first thing. You have to do univariate logistic regression. So univariate logistic regression, you do one by one, and that's a lot of work in SPSS. That's a lot of work in Starter, but RStudio makes that easy for you that you can do it at once. Look at this magic. So this is, I'm going to call this as table 3. So table 3, okay, so this is the code that we are running. So this is the command, table regression, the name of the data, ICU, okay. Method, we are going to use generalized linear model, okay. And then Y means the dependent variable to survival outcome. The method argument, we're just going to list and family, binomial, so this is binary logistic regression, exponentiate, true, and then include, I'm going to list all the variables that I want. So here you can remove or you can add some, okay? So for you, as you get this code here, you're just going to replace with the variables you want. So I'll just click here, control enter, and boom, okay? We have our model done, okay? We have our logistic regression analysis done. So, and then to view our logistic regression analysis, we're just going to type T3, control, because this is the way I named my logistic regression table, and view this and watch magic. Look, this is, we have the number here, we have the odds ratios nicely put already, 95% confidence interval already put for us, perfect, p-value already put, and we can see here age is significantly associated with the survival outcome, okay, just on its own univariate analysis, okay. And then also infection, okay, infection, and also emergence, okay, whether the case was an emergence or not, whether the case was an infection. So here we have determined that infection, emergency, and age were associated with it, okay, and we can see the confidence intervals here and the odds ratios, but like I said, I'm not interpreting these results yet, okay. Now we have to, after doing the univariate logistic regression, we have to do the multivariate logistic regression, meaning we are accounting for the confounding variables, okay. Now, like I mentioned earlier, for you, this seems like it's survival analysis, but like I said, I'm not doing survival analysis, okay. Survival analysis is done in a different way, okay. The topic is survival analysis, but I just want to demonstrate how you're going to do. It's not everyone who's going to do survival analysis. So let's look at this. So this one now, we're doing binary logistic regression, univariate, multivariate logistic regression analysis. So I'm going to call this as mode 1 as the object, okay, generalized linear model, then my outcome variable, survival outcome, and then I put that, I don't know what it's called, whether it's tilde, age, sex, infection, all the variables, then the data name is ICU, then family is binomial, okay, then control enter, okay. So we are fitting the model, and then now we are going to generate this model summary, okay. So T4, we're going to name it T4, table regression model, exponentiate true. So let's run that, control T, and the table is ready. To view the table, we can just click T, we can just write T4, okay, T4, control enter, and boom, okay. We can see now we have, so now this is a logistic, this is now a, what can I call it? This is a multivariate logistic regression. You can see even the age. This one was 0.006, but you can see here it has changed, and infection is no longer significant here, but emergency and age. So on univariate, we found that age and infection and emergency were statistically associated with the outcome. But here we've only walked away with two variables, age as well as emergency of the case. All right. So, and we can see the odds ratios here. But like I said, I'm not interpreting here. I will do a separate one to interpret. Now, remember, I promised that we are going to merge these tables. We are going to merge these tables into one. Amazing. Let's look at this. So we're going to merge table 3 and table 4. And the code to run is the table merge, okay? So you put table list there, T3 and T4, okay? And then here, table spanner, this is the tab spanner, meaning the titles on top. So you can write whatever you want here. Okay, so I'm going to run this, Control Enter. So I'm merging. So I have merged. And if I want to view a merged table, I can just write T5 here. Okay, I can just write T5 and then Control Enter. Okay, and look. Oh my God, everyone should run our studio. Look at this amazing publication ready. People, if nothing amazing, if this thing doesn't amaze you, I wonder what else will. In statistics, this is magic. People who have analyzed data before, they understand the stress of generating this table. Like, you have to design it in Microsoft Excel. But look at how amazing our studio has done it for us. Look at this. And it doesn't just end here, okay? You've seen we've merged two tables, invariant and multivariant analysis. It doesn't just end here. Now let us save this into a Word document. So we'll begin by converting it into a flex table. So as flex table, that's the command to run. So Control Enter, and then I go, and then I'm going to create a new Word document by running that code, and then I'm going to add this table into the document. Control Enter, and I'm going to save this into the document. I'm going to save the document. Control Enter, and if I go into my files, okay, that's the importance of setting a working directory. I'm going to find that there's a new document here, and I'm going to open this document, and I'll find my magic. My cake is ready for eating. Okay. Look, people, amazing things are happening in our studio. So why are you using SPSS? Why are you still using SPSS? Of course, you can, sometimes I use SPSS for some certain parts, but you can see how amazing this table is already. Publication ready, like there's zero work I have to do here apart from simply interpreting. People, this is something amazing. This is great work, just simple code, you do amazing work. So thank you so much, and you can do this in actually 15 minutes because I was talking, so the video might have taken so much time, but I promise you, you can do this in 15 minutes. 15 minutes, you are done with your analysis. That is it. So I hope you found this video very helpful. So in the next session now, we are going to interpret these tables that we have generated. How do we interpret and how do we report? Thank you so much. God bless you all.